Hello, this is Melisha and Nicolas doing our presentation on hyperbolas. First, I will let y'all know what hyperbolas are. And they are a collection of points in a plane such that the difference of the distance from the point F1 and F2 is a fixed constant. The points F1 and F2 are called the foci of the hyperbola. A hyperbola is a conic section defined as the locus of all points. The curve represents the function f of x equals 1 over x and is made up of two continuous curves known as the branches of the hyperbola. The line segment joining the vertices is called the transverse axis. The point midway between the foci and line on the transverse axis is called the center. Over here we have the formulas for a hyperbola whose transverse axis is horizontal. You see the formula is the quantity f minus h squared over a squared minus the quantity y minus k squared over b squared equals 1. As you see, the center is hk and the vertices are h plus or minus hk. Define the foci, which is represented by c, is the square root a squared plus b squared equals c squared. If the transverse axis is horizontal, the transverse axis, the foci are h plus or minus c k. And the isotope of a hyperbola whose transverse axis is horizontal is y equals plus or minus b over a x. For a hyperbola whose transverse axis is vertical, the formula is the quantity y minus k squared over a squared minus the quantity x minus h squared over b squared equals 1. And the isotope is, you find the isotope by y equals plus or minus a over b x. And you find the foci the same way as the one with horizontal, and that would be h k plus or minus c, and the vertices will be h k plus or minus 8. So we'll have Melisha come up and present y'all with some examples if y'all don't really understand what I was trying to say when I was explaining this from the notes.
Okay, so here we have a hyperbola with a horizontal transverse axis. And like we said, the equation for this would be x squared over a squared minus y squared over b squared equals 1. And the transverse axis will be going, the branches of the hyperbola will be going from up to down on a horizontal hyperbola, and on a vertical hyperbola they will be going from left to right. Okay, some examples. The general formula of a hyperbola is ax squared minus by squared plus cxy plus dx plus ey plus f equals 0. Some examples of how this formula can be put into a hyperbola is 2x squared minus 3y squared plus 4x minus 7 equals 0. Or you may see it as 2x squared minus 5x plus 3 minus y equals 3 times the quantity y minus 1 squared. Or you may see it as this: 4x squared plus 3x plus 7 equals the quantity 2y minus 3 squared. In a vertical hyperbola, you may see an equation as y squared over 5 minus x squared over 11 equals 1. Or in a horizontal, you may see it as x squared over 4 minus y squared over 16 equals 1, or x squared over 16 equals y squared over 36 equals 1.
And if there are no numbers beside the x or the y, the center of the hyperbola is 0, or is at the origin. And with the general formula, the x squared and y squared will always have different signs.
And these dotted lines on the hyperbolas are called the asymptotes. The vertex is found in the middle of the hyperbola, well, one of the branches of the hyperbolas, and the focus is found a certain distance away from the vertex on either on the x or y axis, depending on whether the hyperbola is vertical or horizontal. The transverse axis is the distance from each vertex on each branch of the hyperbolas. And the foci of the hyperbola is c units from the center, where c squared equals a squared plus b squared. And the eccentricity is E equals C over A. And the eccentricity is always going to be greater than 1, whether the hyperbola is vertical or horizontal.
And this concludes our presentation on our project of hyperbolas. I hope you really enjoyed our presentation and really got a hold on to what we're trying to say in this video.